So we've looked at stress concentrations before, and then we went, okay, well, for a normal axial loading, we went, well, that normal stress is just going to be K times P divided by A, which is the stress concentration factor times our definition of stress. And then for our shafts, we did the same thing. We said that, okay, well, we've got a stress concentration factor times our normal definition of stress, Tc over J. So it should come as no surprise for bending. We've got our Mc over I, and then we're going to multiply it by a stress concentration factor. That's all there is to it. Everything is done the exact same way. And let's just look at a couple of the charts. So here's a couple of the charts, a couple of the bigger ones with bending. So we've got one that's got a slot keyway cut into it. I have one that's got a smaller bar as opposed to a bigger bar. Once again, the stress will concentrate at the smaller of the two. And we go about calculating out K the exact same way we would before. We look at the chart. So in this case here, we've got large D over small d to identify the lines. We have R over D to identify our x-axis. We use that to trace back to our stress concentration on the Y. Over here, when we've got a slot, once again, large D over small d to identify the line, R over D on the bottom to identify what the K value is. There's not much to say about this because we've been doing this, we've done this with axial, we've done this with torsion, now we're going to do it with bending.